Okay, there we go. All right. So, good morning, everyone. It's still morning. Today we're going to be talking about two-step equations. So last week we did a little bit on one-step equations, how to solve them algebraically. And today we're just going to be expanding that into the idea of two-step equations. So for a lot of you, this may not be new. That's okay. I just want to work through it at a reasonable pace just so that everyone's on the same page, because that's really what this course is all about. Making sure that everyone's on the same page before you do the more involved grade 10, 11, and 12 courses for math. So, two-step equations are really important as well because they involve both a multiplication and a division and an addition and a subtraction. So you'll see a lot of linear equations written like this, where a lot of things are in the form of y is equal to mx plus b. So you've got, in this case, we've got two variables, but we've got a multiplication and either an addition and a subtraction. So it becomes very useful to be able to deal with these two-step equations. So the process for solving two-step equations is quite similar to the process of solving one-step equations. All you have to do is apply inverse operations. But in this case, we have multiple operations that we want to undo. So we can say that we're undoing operations in reverse bedmass order. Until we have the variable isolated. So the rule that we're going to be working with instead of bedmass is going to be samdeb, where we're going to be undoing our subtractions and our additions first, and then we're going to be undoing our divisions and multiplications, and then undoing our exponents, and then lastly, we do our brackets. So what that means is that if we have anything in brackets, it needs to be totally saved until the end when we're doing two-step equations. So for number 1, we have 6 is equal to a over 4 plus 2. And we want to solve the equation, which means that we want to find the value of a. So when we're undoing this, we want to look at a reverse bedmass order. So we've got subtraction, addition, and yeah, we've got an addition here, the a over 4 plus 2. So we're going to want to undo that. So we can say, I'll just zoom in a bit here. We can say then that this is equal to 6, and we want to undo the addition. So the inverse operation of addition is subtraction. So instead of adding 2 on both sides, we're now going to be subtracting 2. So 6 minus 2 is equal to a over 4 plus 2 minus 2. So we've done the same thing to both sides. That's always going to be very important, is that whatever we do on the left side, we do on the right side, and vice versa, because otherwise you're changing the value of the equation itself. So in that case, we now have 4 is equal to a over 4. We've eliminated the addition that was previously on the right-hand side, and now we just have a division. So if we're following along with our samdeb, we've carried out our subtraction addition. Now multiplication and division is next. So we have a divided by 4 on the right-hand side. So to undo that, the inverse operation of division is multiplication. So we have 4 times 4 is equal to a over 4 times 4. Okay? Then that will lead us to 16 is equal to a, because a divided by 4 times 4, that's just a. You can think of it as a fraction if you really like. If you want to think of it as, let me just write this in a different color. You can think of a over 4 times 4 over 1. And that's just going to get you 4a over 4. And that would obviously reduce to just a. because you've got the same thing on the numerator and the denominator. Okay, so back to our equation. We said that 16 is equal to a, and there we have it. You can also express these, you can essentially flip an equation, like the left-hand side and the right-hand side, you can switch them around with an equation. That's perfectly acceptable. So if 16 is equal to a, we also know a is equal to 16. And that's going to be our final expression. A is equal to 16 is going to be the solution to this equation. So we'll do a couple other examples before I turn it over to you. So for number 2, we've got negative 6 plus x over 4 is equal to negative 5. So going through our SAMDEP, the first thing that we're going to want to get rid of is the addition on the left-hand side. So we had negative 6 being added to x over 4. So to undo that, we're going to need to subtract negative 6 from both sides of the equation. And if we subtract negative 6, that's the same thing as just adding 6. So we've got negative 6 plus x over 4 plus 6. That's going to cancel out the 6's. And that's equal to negative 5 plus 6. Okay, and then we just clean it up a little bit. So now we have x over 4 is equal to negative 5 plus 6. That's just 1. So x over 4 is equal to 1. And now we have a division. So once again, we're going to need to multiply both sides by 4. Once again, 4 times x over 4, that's just going to reduce down to x. And then 4 times 1 is just 4. So x is equal to 4. Whenever you're solving these two-step equations, just what I want to make clear is that you should always show at least one intermediate step. So you don't need to go do through this in 4 different lines like I've done here. It's perfectly okay if you just go straight to there. So you apply the addition and you've created x over 4 is equal to 1. And then you want to obviously put your solution. The steps in between, you should put them if you think that you want to keep track of them. Like if that's what you need to keep track of the solution, absolutely go for it. But at the very least, you're going to want to put, essentially every time you undo an operation, you'll want to restate what is the equation now. So we've undone the addition. What does the equation look like now? Now we undo the multiplication. We have our variable. So yeah, you want to just show those key steps in between. So at least 2 steps for this one. Any questions so far? Great. And we'll do just one more before I turn it over to you. So in this one, we have 9x minus 7 is equal to negative 7. So once again, subtraction and addition we carry out first. So 9x minus 7 plus 7 is equal to negative 7 plus 7. And what that leaves us with is 9x is equal to 0. So in this case, we have a multiplication, 9 times x, and that's going to be equal to 0. So if you want, you can just say, hey, I think the only thing that you multiplies with anything to get 0 is 0. Therefore, x is equal to 0. But you can also do it the same way that we've been doing it. Just divide each side by 9. So we're going to undo the operation of multiplication. So 9x divided by 9 is equal to 0 over 9. And then that gives us x on the left-hand side is equal to 0. Because 0 divided by anything, that's just 0. So there's our answer. X is equal to 0. Okay. Any other questions? Awesome. So I'm going to give you some time now. We'll do maybe 10 minutes, you can work on this. And then I'll just take up the rest of the first page, and then we'll work on something else afterwards. Okay, so for the next 10 minutes, just get as far as you can through this page as you can. And I'll come around if you have questions.